Today we're going to peek behind the curtain of a modern warehouse. We're going to explore how these massive, complex operations use smart systems to handle the one thing you can absolutely positively count on, the unexpected. Let's dive in.
You know, in a perfect world, in a perfect warehouse, every item is in its perfect place, every delivery is exactly right, and not a single machine ever breaks down. Sounds nice, right? But come on, when is anything ever perfect? What happens in the real world? Yeah, reality is a whole lot messier. And by messy, I'm talking about things that happen every single day. A worker goes to pick an item, but the full quantity just isn't there. Your scanner, the lifeblood of the whole place, right? Suddenly decides it can't read a label. Or maybe the bin that the system swears on its life is empty. Well, it isn't. And look, these aren't just little annoyances. They can stop the entire operation dead in its tracks.
So how do you deal with all that chaos? You can't just have a manager sprinting around with a fire extinguisher all day, right? No way. The solution has to be baked right into the system itself. And that brings us to the system's really smart response, a way for it to understand the problem and automatically kick off the right solution.
The secret sauce here is something called an exception code. And I know, that sounds super technical, but don't worry. Just think of it like a digital flare gun. A worker on the floor spots a problem, they fire off the right flare, that's the exception code, and boom, the system knows exactly what's wrong and, more importantly, what to do about it.
So what's the big deal with these codes? What makes them so powerful? Well, let's break them down, because they're way more than just some simple error message. Think of them as intelligent instructions.
Okay, so here's the textbook definition. An exception code is basically a system code that does two key things. First, it pinpoints a very specific exceptional situation, and second, it kicks off an automated follow-on action. And honestly, that second part, that's the real game changer.
But how does the system know which action to take? Well, it's pretty clever actually. The code is split into two parts. You've got the business context, which is just the what. What are you doing right now? Putting stuff away? Picking an order for a customer? Then there's the execution step. That's the how. Are you using a desktop or are you out on the floor with a handheld RF scanner? Putting those two pieces together gives the system all the context it needs.
And there's a really good reason for setting it up this way. I mean, think about it. You can't just overwhelm a worker with a list of 50 different codes on a tiny little handheld screen. That would be a nightmare. So by knowing the context, the what, and the how, the system is smart enough to only show the handful of options that actually make sense in that moment. It's just smarter and way easier for the person doing the job.
So here's the main takeaway. The code isn't the end of the story. It's just the trigger. The real magic, the real power is in what happens next. And that's where these follow-on actions come in. You can think of them as the automated brains and brawn of the whole operation.
And what can these actions actually do? Well, pretty much anything you need. It could be triggering an internal process like, hey, find a new bin for this product. It could be starting a workflow to ping a manager's computer. It can change an item's status, say blocking a bin so no one else touches it. Or it can just create an alert in the system. It's like having a whole digital toolkit of automated fixes ready to go.
Okay, that's enough theory. Let's get practical. Let's walk through a couple of real-world scenarios so you can see exactly how this plays out on the warehouse floor. Okay, scenario number 1. This is a classic warehouse problem. It's called a partial pick denial. The system code for it is BIP. So, picture this. A worker's scanner tells them to pick 10 items from a bin. They get there, they do a quick count, and there are only 8. The system says 10, but their eyes say 8. What do? Simple. The worker just keys in the code BIP and check out what happens next. All automatically. The system doesn't just throw up an error. No. First, it creates a new task to get those missing 2 items from somewhere else, so the customer's order still goes out on time. Then it triggers a physical inventory count for that original bin, because something's clearly wrong. And finally, it blocks the bin. Nobody else is going to get sent there until that count is verified. And just like that, in seconds, the problem is identified, contained, and the solution is already in motion.
All right, let's look at another one. Scenario 2, inbound delivery difference, or DIFD. This time, we're on the receiving dock. A truck from a vendor drops off a pallet. The delivery note says there should be 100 units on it. But as the worker starts to put it away, they count, and there are only 95. A classic short shipment.
Now the fix for this is so slick. The worker just enters the exception code DFHD and types in 95. That's it. The system handles the rest. It automatically adjusts the inbound delivery, it corrects the goods receipt, there are no frantic phone calls, no messy paperwork. The digital truth instantly matches the physical truth. And that means your inventory is accurate from the moment it hits the door.
But wait, it gets even cooler. This whole thing isn't just for people on the floor. The system itself can be the one to spot a problem. Let's say it's building out the day's work and realizes, uh-oh, I can't find any stock for this order. It can trigger its own internal exception code completely on its own. It becomes a proactive system, finding and flagging issues before a human even lays eyes on them.
So, when you step back and look at all this, you realize it's not just about fixing one little error at a time. This is about building a warehouse that's fundamentally more resilient. It's about designing a smarter, self-correcting operation from the ground up.
Here's the bottom line. Exception handling is what gives a warehouse its flexibility. It's what turns it from a rigid, fragile process that shatters at the first sign of trouble into a truly adaptive system that can roll with the punches of reality.
And the big picture benefits? They're huge. You're minimizing disruptions so the work keeps flowing. You're keeping efficiency high because problems get solved on the spot. You're letting your managers actually manage instead of just firefighting all day. And at the end of the line, you're creating a supply chain that's just plain more accurate and reliable. That's a win for everybody.
So, let's leave you with a question to chew on. Today we've seen how these amazing systems react to problems, but as we bring more automation, more AI into the warehouse, what's next? How will these digital nervous systems evolve? Could we see a future where they can actually predict problems and solve them before a person even realizes something was about to go wrong? Now that is the future of logistics.
Welcome.